Everyone can see the mirror, right?
Yeah, it's there.
Okay, cool. So overall, so this is like a IOQM session. We will not be focusing on the theory part of IOQM or like the uh, or how to solve problems in IOQM, but more like the general tips and tricks. And also we will look at subject-wise what is essential for IOQM, what you need to know, what is most what is highly probable to come in IOQM and stuff. We'll also look at one or two problems regarding those subject-wise when we come to them. Okay, so we'll start with some general ideas. So first thing to do is key, you should give a lot of mocks. Now you have like 1 month till IOQM. Do as many mocks as you can. We will also have a mock in OMC, obviously. Um, the thing is, you should try various strategies during mock, uh, because there might be many strategies that work for you. For an example, doing problems in a linear manner is not necessary. What you can do is, you can do all the two, like this worked for me last year. I did all the 2 markers, then I did all the 5 markers, and then I did all the 3 markers. This helped me because for the time to the mark ratio, it just worked better for me. So you might try the various strategies in mocks and try to work out what's the best for you. Uh, yes, preferably time. That is true. You should just give your mocks very seriously. Just give them as they are like as we're giving the IOQM. Second thing to note is key, if you're trying a problem, it shouldn't happen that you're trying that problem and you just stuck on that problem for like 20 minutes or stuff. 20 minutes is a lot in IOQ. In general, when you're doing like math only, you generally don't care about time. But here you just need to know when you want to quit. Since there are like a lot of problems, you just need to get an idea ki at this point I can't do anything else, or at this point, even if I can do something else, it is going to take a really long time. So maybe at one point you will find ki, okay, I know how to complete this problem from here, but it's a very long batch, or like it's going to take me at least 10 more minutes to solve, and I've already invested 6, 7, 8 minutes on this. So at that point, you might want to save it for later and just skip it for now, or or yeah. So just you should know when to quit. So like the some of the reasons for quitting might be so subject. So there's a subject preference for everyone. So I had a strategy last year ki if I can't do like I was struggling with IOQM Geo. So what I used to do is if I can't do IOQM Geo in like 1 or 2 minutes, I used to just quit it and go ahead. Like in the first attempt, I don't think I used to attempt IOQM Geos at all because like the computational part used to be tough for me. So you should identify during mocks what is tough for you, what works best for you, what subject you would like to skip on the first try and stuff. Second is obviously difficulty. If you think the problem is too difficult, you should just try skipping it for the first that time. And like that, you need to make a upper bound on the time for first approach. Like you should obviously try various approaches if you don't get one, but shouldn't just like go on trying one approach for a very long time. Also, if you don't get like any ideas to solve the problem, or you don't get any what do you say, you don't get how to approach the problem in like 2 3 minutes, it is generally a good idea to just skip that problem for that time and move ahead. So if you like overall work on when to quit problems, it would be very beneficial for you to manage your time effectively.
But even if we know that we can solve this problem, then too we can skip. We should skip.
Yes, I mean that is you are the best judge, right? Because let's say you are solving it through 2 marker or even 3 marker for that reason. You have invested a 6 7 minutes and you have got like okay now after this I just need to like check out this 10 like let's say 7 8 cases and then I'll be done. So that will take another 7 8 minutes for that. So do you think it's really worth investing 7 8 more minutes to solve the 2 marker, or can you utilize that time beneficially for something else? So this what do you call um, this idea or this thing you will get by solving mocks, that you finally you will be your best judge ki how fast I can batch this.
Doesn't that also
So
matter on the difficulty of the paper and how we gauge it?
yes, I mean difficulty of the paper is obviously essential, but since you will be solving it at the end, so for example now I think everyone knows that 2024 IOQM was much easier than 2023 IOQM. So we don't know what this year's difficulty will be. So it will be a surprise to you on the exam day. So based on that, you will have to just develop an intuition key, how long it will take me to finish this problem from here, or how difficult does this problem look. And I think that intuition you can develop from doing a lot of mocks. Like you will do mocks of approximately a very difficulty range. So that would help you. That would help you gain a very good intuition. Okay, give me.
Okay, another important thing to consider is the time to marks ratio. So like for 2 markers, you shouldn't give more than like 5 minutes because they're not worth that much. For 5 markers, you can even dedicate up to 20 minutes if you're sure that you will solve it, because then like 5 marks is a huge amount. Like for example, in the 2023 IOQM, there were 10 marker questions. So like I spent like half an hour to 40 minutes on the 10 marker, and like that was the thing that made the difference between qualifying and not qualifying. So yeah, uh, 5 markers you should give importance to preferably.
Yes, that is absolutely correct. So this is a very important thing. Another thing is IOQM is computational. So I mean, for some reason, for good or for worse, your accuracy matters. So just recheck every step twice. Avoid making series. I mean, I know it's easier to say don't do series than to actually do series. But you should just try to focus more, recheck every step, and yeah. So during mocks only you can just like develop a habit to think of every step consciously. Like there are a lot of things that you compute. Sometimes you just do it mechanically without thinking about it. Try to avoid that. Like whatever you write, whatever you do, just to think of it consciously and just check once if you are doing it correct. Okay, another important thing is, IOQM is OMR type. So there are generally two strategies for marking OMR. One is you mark OMR at the end. So I think I'll let Atharva talk about this in a minute. I'll just talk about the other strategy for a minute. So what I used to do, I used to mark OMR immediately after doing the problem. Like if I do a problem and I'm like 100% sure about it, I used to just mark it at that point. If you do this, an important thing is after doing that, you do not look at the problem again. Like you do not even think of that whether I did it correct or wrong. The point is, if you messed it up by mistake and you realize during contest, it will affect your problem solving for other problems, because there is nothing you can do about it now. You have already marked the OMR and now you think, oh, I should have done this correctly. So if you have marked it already, you do not look at the problem again. Just it's over for that point and you just move ahead. For marking OMR at the end, I think Atharva can talk about it better. I'll let him talk.
Yeah, so this was what strategies that I used during IOQM. Like I used to complete all of the problems, like all of the problems I could do in the first 2.5 hours. And then the last 30 minutes, I would just save for marking. So like in this marking time, what I would do is I would recheck every single problem, like briefly, and mark it after this rechecking. So like basically, if you've made any tiny silly errors which you can catch in like 1 minute of checking the problem, you will catch them in that last minute. And so like you can be sure that the marking is correct. And yeah, that's basically it. You just need to remember to leave enough time to mark. Like, you don't have to like spend the last 10 minutes marking, because in that case, you might make some errors in marking. Like you need to dedicate like at least 15 minutes.
Yeah,
Uh,
so that is it. So market, even these are two strategies. You can develop some of your own also. So just try these during mocks. See what's best for you again. Okay, now this is subjects. So usually in IOQMs, what most of the people face is ki algebra, combinatorics, and number theory. These three are easier. Uh, but like geometry, some people find it extremely, I would not say difficult really, but extremely like hard to do during contest, because computational IOQM geos are almost entirely bash. They're either length bash, trig bash, chord bash, and stuff. Yeah, annoying is the more real word. Like it just takes a lot of time during contest. So unless you are really sure about geo, try to focus on the other three for the point. If you know that you are like really good at geo and you're really good at bash, you can do geo, no problems about that. On the otherwise, try to focus on the other three. They are more, I would say, solvable or more doable during contests. Obviously, two marker geos and like two marker geos, three marker geos is doable. So you should try to do that as much as you can. Oh wait, there's
Wait,
something
have you
inside.
inverted the inequality somehow?
No, no, it's like importance based. Like you should focus more on these subjects than geo.
Okay, okay.
What is bash? So bash is yes, precisely reducing beautiful geo to ugly algebra. So basically, you transpose the geo into like a coordinate Cartesian plane or do it Cartesian plane or do it like trigonometric identities like sine rule, cosine rule, and stuff. Or length bash is just like you chase some random ratios, use Ptolemy stuff like that. That is bash. That is length bash. So since IOQM is computational, they can't ask you to prove that ABCD is cyclic or something like that. They always need to ask you, okay, compute this given this and this. So for that, the computational things are of utmost importance in IOQM for Geo. Okay, next thing is know your bash limit. Like everyone has a bash limit. For bash, I don't exactly mean geometry, but like a general bash like case bash or something like that. So you can if you reduce a problem to a thing, maybe like there exists a efficient way reducing it even more, but you can also start like just manual checking cases directly. So that depends on how fast you can check them or how fast you can batch the cases. So this is the efficiency versus batch thinking. So if you are confident enough you can batch this pretty quickly. Just don't care about efficiency at that point, and don't try to think how else I can reduce this. Just go and try to complete it in the given time. uh, so yeah, again, it's a very personal decision because everyone will have different speeds of checking and things. You should develop this intuition over time. Hmm. So okay, so the next thing is mark all the questions. So obviously you won't be, I mean, not obviously, but like I should say, ideally you shouldn't be able to solve all the questions. You will be able to solve like some of those. Let's say solve 20, 25 questions or like whatever. In the rest of the questions, if you have an educated guess, you should make that guess. So if you have tried that problem for some time, or like seen that problem, you have some guess ki what the answer is going to be. You can try guessing. You should obviously try guessing that because like thing is there is no negative marking in IOQM. Even if the problems that you have not given a serious attempt, like you have just read and left it, you can like just try marking one of the things like 12, 24, 36, 25, 30, 50, 72, 48, 96. Like stuff like these are good numbers. These recur a lot in IOQM because their prime factorization is very nice. So basically from the problem, if you can get an idea of size, like for example, I see a problem and I'm like, huh, the answer should be approximately in 10 to 20 range. Then you can just mark some of the good numbers there. Also, like if you are doing geo, then some sides will be given to you. If they are like let's say 8 and 9 or something, then answer turning out to be 28 is quite rare because where will the prime factors of 7 come from unless you add or subtract something. So then you should like just mark something a good number which is 2 and 3, like which is a prime factorization of 2 and 3. So I say 24 or something depending on what size you narrow it down to. uh yeah, that was the thing. So you should mark everything and like leave 10 15 minutes at the end for this to ensure that you're going to do this. Okay, I will let Freddy explain the next points because he's good at it.
Okay, so yeah, another very extremely important point is read every single problem carefully. This is like quite important, and I have lost a lot of marks due to this as well. But yeah, you need to read every problem very carefully, like especially the signs, and like while writing down as well, you need to like if you're copying the statement of the problem, that's it, like the inequality or something. So you need to like make sure the sign is correct. And for the combinatorics problems especially, you have to read the words like ordered, unordered very carefully because like uh, it changes the answer by quite a lot.
Atharva,
Sorry.
is the screen visible to you? Because I don't think what I'm writing is visible.
Oh, hang on, I'll just
It is visible,
Okay,
yeah,
now
okay,
it's
like the
visible.
eighth one.
Yeah, okay, cool.
yeah. Then another important thing for alchem is like you need to know like some specific calculations beforehand. so that you don't have to work everything out during IOQM. Like you should memorize like the first few powers of all numbers from 2 to 10, like up to the fifth power around. Like this is not that hard actually. It's like just when you know for the higher numbers, you basically know everything for the lower numbers as well. Then you need to like know like the first 20 squares, and also like the first 5 to 10 cubes as well. Like these are quite helpful during contest. And another thing that is important is some nice like calculations or some nice factorizations. For example, uh, there's this common factorization, 7 into 11 into 13 is 1001. So like if you see a repeating number like 123 123, so you can assume without like any hesitation that 7, 11, and 13, all of them divide. Similarly, 3 into 37 is 111. So like this is another important thing. Um, because yeah, you see repeating digits, you can assume that 37 divides it. So like if it asks what is the largest prime dividing this number, you can say 37 like quickly. Um, Another important thing is like this is more of combinatorics thing, but like yeah, the Pascal's triangle gives you the powers of 11. So like these kind of tricks would help you a lot in contest. Like the first, the nth row of the Pascal triangle is basically the nth power of 11. So yeah, these kind of things are important to know during contest.
Can you repeat the Pascal triangle point?
Oh yeah, so like you guys know the Pascal's triangle, right? It's like basically this thing. Um,
Yeah.
can you like draw it out?
Okay, sure. So
Yeah, so basically in each row, like this number is going to be the sum of the two numbers which are above it. So like
Yes.
these are also equal to the powers of 11. So like this is the first row. Like assume this as the zeroth row.
Oh, okay.
This is 11 squared and so on. And like when you get to the fifth row, like it becomes like this. Like this is not directly true. Like you should assume this as a kind of carryover. So like it's 1, 5.
Like binomial.
Yeah, yeah, it's basically binomial. Like you're taking the binomial expansion of 10 plus 1.
Yeah.
So yeah, yeah, this is an easier way to calculate powers of 11. So yeah, I think that's all for the general tricks.
yeah,
Okay, let's move on to the subject-wise tricks. So we'll start with algebra. Give me a second. Start with combi. No, we'll start in the normal alphabetical order. Okay, so algebra has like a few tricks that you can do. First of all, you need to know like the basic identities, like a plus b minus b is a square minus b square, and like even some less well-known identities like a cube plus b cube plus c cube minus 3abc factorization. So like these are important identities to know. Then another thing you can do is you need to like substitute nice values in the equations. Like for example, there was this problem in IOQM 2024 or 2024 P5, I think. So in the problem, you just basically had to substitute uh, x equals y equals z equals 1, and like the problem was basically over. Like let me just copy the exact statement. Yeah. So if you notice, now there are no restrictions as such given on x, y, and z, right? So if in this kind of scenario, you can just assume them to be whatever you want, whatever makes the calculation easiest to do. So like in this case, by substituting 1, 1, 1, you just get like a equals 3, b equals 3, and c equals 8. So yeah, this like instantly solves the question, and you don't even need to do anything. And but the important thing to remember is that there have to be no conditions given in the question. Like whatever nice values you have, like they have to satisfy conditions. So in case they don't, then like don't fall into this trap of like substituting random stuff, and it won't
Yeah,
work basically.
yeah. So basically, you need to check ki every condition satisfied. Also check that what the x y z belong to. Like here, it is not mentioned, but sometimes there might be positive reals, positive integers, or integers, or just something like that. So in that case, you choose something like zero, and you will be cooked. So just ensure that all the conditions are satisfied. It's in the domain and stuff. Also, I mean, in such problems, you can obviously expand and check, but this is just like a quick way to get the answer because if it holds for, if you are able to calculate, it obviously has to hold for this. So it's a shortcut.
Yeah, and another important point said in chat, look at the domain of the problem. Like if it's given positive integers, do not take zero as an answer. And if at any point of time you're like having this kind of thing where the denominator is like coming out to be zero, like that is also a bad substitution. Even if it like gives you some value, that value might be wrong. So yeah.
Yeah.
Okay. So the next important thing is in FEs, which was like it was just like not very rare in IOQM, but like there are a few problems. But yeah, in FEs you need to like guess the function beforehand. So
Like some of the common functions can be f of x equal to x, x square, like some linear function, or some like a very weird quadratic functions. I don't, whatever. You just need to find it, guess it. Guess you will be given some values and some relation. So you can try to guess the function. If you guess it correctly, you will mostly not need to do anything else. But again, the thing is that there might be multiple solutions. So once you check the thing, you should just check if all the conditions are satisfied. Because like if there are multiple answers, like x square and cx, and you just forgot that there was a word linear written there, you will just be you will just mess it up. So if you are not solving it completely, so both of these strategies, you are not actually solving the problem, right? You are just guessing the answer and writing it. So at that point, you should be very careful that have checked all the conditions and it actually fits in the question.
yeah, yeah, yeah. So another thing is give me a second. Yeah, another thing is inequalities in IOQM. So like you're not going to get asked any hard inequalities in IOQM. All you need to know is the AMGM, like the complete AMGM inequality. Then Cauchy-Schwarz, smoothing, and Tito's lemma. But Tito's lemma is basically Cauchy-Schwarz. So yeah, you need to only know three basic identities, inequalities. In case anyone doesn't know, this extended form is like I write for two variables.
Like, what do you mean by smoothing?
Sorry.
What do you mean by smoothing?
Oh, in smoothing, you basically like for example, if it's given a plus b has a constant sum, so like the maximum value will usually be towards the middle, like when you take a equals b, or like in some cases it could be like when you take a and b as extreme values. So yeah, that's basically kind of smooth.
So to give an example, if you have some constant and you're trying to maximize the product, you just try to bring them closer. So you will have something like 10 into 20 is less than 11 into 19. I hope this works. Yeah, it is working. This is like 209 and this is like 200. So this will be less than 18 into 12 and stuff. Maximum will be achieved for 15 square.
Also remember while applying these inequalities that these inequalities only hold for positive reals. So yeah, don't apply them on when the question hasn't specified that the numbers are positive reals. Okay. So yeah, the next important thing is Vita's relation. Uh, Vita's relation, like for the coefficients of the polynomial. Uh, Many questions based on this have been asked in IOQM, and like they're asked every year. So yeah, uh, you should definitely learn this relation for like every degree polynomial. I mean, learn the pattern basically. Do not confuse this with beta jumping. Beta jumping is not used in IOQM at all. Yeah.
Yeah, for Vita's relation, also just ensure that you're taking the sign correctly, because many times, like, you're taking the product of roots and you forget that it's a cube and just take that it's alpha beta gamma. Like it's just a naught or one a1 or something, a n or whatever. So just ensure that you're taking the sign correctly of -1 to the n. Yeah. So for the squares, or for the degree 2, 3, 4, 5, like for the basic degree, it should just come naturally to you as you do things, because then it would be it would be better for you to just memorize them extremely good. So because that would make the less chance of error.
Okay. For inequalities, I forgot to mention one thing. Like if you have a kind of question like a plus b plus c is equal to 5, and they're asking you to find the maximum value of say a b square c square. So in this kind of case, what you want to do is you want to split the ABC, like this is going to be AMGM, right? But you want to split A, B, and C in a way so that it will, on the RHS, you will get A, B square, and C square. So like what you will do is like here you take A plus B plus C is equal to A plus B by 2 plus B by 2 plus C by 2 plus C by 2. So this kind of substitution will give you like nice results. I mean, the results that you want to. Like for example, in this problem, you know that this value divided by 5 is greater than equal to the fifth root of ab square c squared. But this value is basically what we're given, that's ABC. So like you have 1 is greater than equal to the required value. So yeah, this kind of substitution is quite useful.
Also, one more thing I would like to add in inequalities is ki if you are if in the final moments you want to guess some answer, it would be a good idea to put all the variables as equal. Like usually equality occurs, or the extremes occur when they are all equal, or they are all at the extremes. So I mean, this might also mislead you somewhere, because like for example, if you try to do it here and you put a equal to b equal to c, it would get you wrong, because equality will be achieved at a equal to b by 2 equal to b by 2. But in general, it's a good, if you are like going to guess randomly, it would probably be good to guess for some things equal. Like what you should take as equal is up to you at that point.
Yeah. So yeah, the last thing for algebra is quadratic conditions. So like basically, what this means is you should like for questions is that both roots are positive or both roots are negative, you should know the conditions based on the coefficients based on this relation. For
Yeah, a good way
example,
to do is it's visualize this. Like J people might find this relevant. So you have a parabola like this of some quadratic relation x square plus bx plus c equal to 0. Okay, they should have roots. So you should memorize this thing as like it's minus b by 2a comma, what is it? I forgot. Minus delta by 4a.
Pure.
Yeah, 4a. So you should memorize this. So you have roots here. So you just want key whatever, let's say it's given key exactly one root between alpha and beta. So in this range. So you need key alpha ka sign, p of alpha ka sign and p of beta ka sign should have a different value. Or like alpha here and beta here and stuff like that. So make sure ki you are doing this correctly. Yeah.
okay, so yeah, now we'll move on to combinatorics. Um,
One more thing I need to ask. If I've studied quadratic or the whole algebra at the J level, do I need to do something else?
I
I would
don't
say
think so, right? If you have done quadratics entirely up to 3 level, it should be enough, I think.
Okay, got it.
Unless Atharva remembers something that we have to add.
No.
Okay.
Wait, do you guys like we have set aside some problems as example problems, but are you guys interested in trying them right now? Like not trying them, but like as we share them, should we give you a few minutes to try?
Yes, yes.
Okay, sure.
Okay, sure, sure.
Yes, yes.
Okay, yeah. Let's move on to combinatorics now. Arnav, go ahead.
Okay. So combinatorics. Okay, so this is IOQM combinatorics. So it has to be computational. Oh, we will give it like when we come to a specific topic. Like we have problems for the specific topics. We will give it when we come to them. It will be soon TM. So for example, combinatorics, almost all the problems that we do, you will have to case bash at some point. Like it's IOQM, so trust that you need to case bash. So you need to be efficient while making cases and like computing them correctly, adding them all together, blah blah blah. Just keep everything in mind. But like this is IOQM combinatorics, case bash is very essential. Some things to remember for that is Fibonacci identities and recursion. Okay, wait. We have some problem for this, like just a example problem. Atharva, you can explain the problem.
Yeah. Uh, yeah. So the first problem is you are given a 2 by n grid, like a 2 by n rectangle of unit squares, and you are given dominoes to tile the plane, like to tile the grid. So they can be arranged in any number, any way you want. So like assume n is equal to, let's say, 7. So like what are the number of ways you can tile this 2 by 7 grid using dominoes? What type of tiles are there? Only dominoes. So like 2 by 1 tiles basically, or 1 by 2. You guys can speak up if you want.
Yes, so it's kind of recursive, right? So start with a 2 by 2, and then for a 3 by 3, you take the n equal 1 and n equal 2 case, and you get something related to Fibonacci.
Yeah, exactly. So what you want to do is consider these two cells, like consider this cell in like specifically. So assume this cell, the tile covering this cell is a vertical tile. So then the remaining grid is a basically 2 times 6 grid. So like if you substitute f of 7, let's say, this is equal to f of 6 plus, and now you'll assume that the tile is horizontal. So then like you can see that the tile over here is also supposed to be horizontal. So the remaining part is 2 by 5. So like this is basically f of 6 plus f of 5. And these are the only two cases. So like you basically get this nice recursion. Then you just calculate f of 1 and f of 2 and like you get the answer. So like yeah, usually recursion problems give you a Fibonacci kind of answer. So like if they have asked for the, if they've asked f of n, then it would be a good idea to guess like the nth Fibonacci number usually. I mean, just work on the base cases and like think of what you can do ahead of that. Okay, another problem is it's like quite similar, but like yeah, you have this kind of grid, a hexagonal grid. Yeah, this is one. Yeah. So how many ways are there to get from 1 to 9? Like you can move to an adjacent cell.
So like either you go in the first step, either you go to 2 or 3, right, and then just recurrence or something like that.
Yes. Yes.
Can you repeat the question, please?
Yeah. So the question is like you have this hexagonal grid, and you want to find out the number of ways to go from 1 to 9, and you can only move from one cell to an adjacent cell.
Can you like go over the same tile twice?
No, sir, you can't. You can't like. Yeah, my bad. You have to like the number on your tile has to keep increasing.
So like on the first few steps, we have two choices every time.
Yeah, exactly. You can either go like if you notice the numbers, you can either go from n to n plus 1, or you can go to n plus 2, right? So this
Yeah.
is basically the same recursion as before. So like f of 9 is equal to f of 8 plus f of 7, and so on. So yeah, Fibonacci is like asked very commonly in IOQM, and recursion as well, like in IOQM combi. Okay.
Yeah, I think we can proceed.
Yeah.
Okay, another problem.
Can't you go from 1 to 8 to 7?
How? What? You can like only go on adjacent cells.
Yes, so 1, 2, 4, 6, 8, and 7.
No, no, like I said, the number on your tile has to keep increasing.
Oh, I see. Yes.
Yeah, I don't know. Go ahead.
Yeah, so another thing is like you should know all the wait, if I recall correctly, that's the 12-fold method. You should know all the like entries of the 12-fold method in a good way. So like um what I mean by that is like all the things like identical coins given to identical children, identical different coins given to different children, different coins given to same children, permutations allowed, permutations not allowed, permutations permutations permitted within the box, permutations permitted outside the box and stuff. Like all such types of problems you need to go over them once. Okay, just for an exercise, we will do this problem very quick. Like it's literally stars and bars, but still. So you have 10 coins which are identical. How many ways are there to distribute between 7 children such that each of them receives at least one coin?
And 9 choose 2.
9 choose 2. 9 choose 6. 9 choose 6. So it's 9 choose 3.
Or at k minus 1.
Yeah.
Yes, that is absolutely correct. Does anyone would like to explain?
Yeah, so we just arrange them and then we introduce bars between them. So that those bars indicate the division of the identical coins. And number of possible placements of those bars is like 9. And we want to place 6 bars so that the division is into 7. So 9 to 6.
Yeah, that is absolutely correct.
Yeah, you need to
So
remember the conditions of the question though. Like this is a very important thing because like if this is not given, then you can like place the bars in the same spot. If you get the point. So like
Yeah, yeah.
a kid can have 0 points. So yeah, you need to consider every single condition. Like distinct and identical are also very important words.
yeah, so just like I said, like it will continue distinct, identical. What is the condition on kids getting coins and stuff? So all the conditions are like at utmost importance in combi. And just to reiterate another earlier point, in combi you need to pay attention of ordered and unordered. Otherwise, you can just get a answer off by a factor of 2 and you won't even know. Yeah. So another thing, again, this is just a prerequisite for exam. Memorize all the small choose and permute. So like memorize all the small factorials, all the small like what is 6 choose 2, 6 choose 3, 7 choose 2 and stuff. This will just help you save your time in exam. So you won't have to keep on calculating what is, let's say, 8 choose 4 or something. So yeah. So like let's say
Yeah.
below 10 or something, just memorize all of them.
Yeah, another like cool thing is the Pascal's triangle. Again, like the numbers in a Pascal's triangle are basically NCR. Like the nth row rth number is NCR. Also, you should. Do you guys know what derangements are? So, like, in
Yeah.
case any of you don't know, a derangement is basically an arrangement of a number from 1 to n such that no number is in its original place. So, yeah, these kind of questions are also asked in algebra. So, like, you should probably memorize the first 4 or 5 derangements. Oh, yeah, that's it.
Yeah. Okay. Another very important thing is invariants. So what are invariants? You will have a class tomorrow, but just for the sake, we'll just do a problem on based on invariants. I think Atharva, you have the problem, right? You can just paste it.
Yeah. So the problem is basically the numbers 1, 2, 4, and 6 are written on the board. And every minute, you will write the smallest number such that none of these two numbers sum to that. For example, in the first term, uh, you can't write 7 because 1 plus 6 is 7. You can't write 8 because 2 plus 6 is 8. But you can write 9 because no two numbers sum to 9. Like three numbers do sum to 9, but we don't care about that. We're just looking at two numbers. So your job is to find out the maximum number that can be returned. So any ideas you can speak up or type in the chat.
Can you just repeat that once again, please?
Yeah, so you're given these numbers on the board and you need to write the smallest number such that two numbers. Yeah, this is the problem set.
Wait, do you remove it? I wasn't there.
So basically 1, 2, 4, 6 are written on the board at the moment. You keep on adding numbers to the board. So for example,
Okay.
next smallest number you can't write is 9, so you add 9 to the board and you repeat the process.
Um,
Oh, any ideas? Like based on the topic that we've given.
You can get that you can never have a multiple of 5 on the board.
A multiple of?
No, sorry. No, that's not. I'm sorry.
This reminds me of base 2.
No, your idea might be correct. Like what were you saying?
No, I said you cannot have a multiple of 5 on the board. But
Oh, okay. No.
true.
This reminds me of base 2.
Yeah. No.
By the way, these two numbers are distinct. Like 9 plus 9 is 18. So can you add 18?
I
Um,
think it doesn't really matter, but sure, you can take it as distinct.
Okay. The answer is 72.
No.
No.
Any ideas? Like we are kind of running out of time, so just give any idea.
Some number invariant, I don't know. As I said, some
Okay, wait. So yeah, when starting this problem, like the thought process should be like 1, 2, 4, 6, and then the next number you write is 9, and like you just bash a few small cases, so you get like I think you get 12, then um
11.
17, yeah,
Sorry,
11,
sorry, my bad.
yeah, then probably like 20, 25, and so on. Okay, now the point is, at this point you should notice that there's a difference of 3, and here there's a difference of 5, and then again 3, 5. And like maybe you try a few more cases and you see that this is repeating. And now what idea you get is that since every like alternate number is basically adding 8, right? So you might want to consider mod 8. So first you notice that the numbers on the board are 1 mod 8 or 4 mod 8. And now what you say is that this number, which is 1 mod 8, will claim that it can't be written as a sum of any two numbers already on the board. And the way we prove that is you have 1 mod 8. So now you're assuming that all the previous numbers on the board are also 1 and 4 mod 8, like basically kind of induction. So yeah, if something has to be add up to 1 mod 8, it will be either like 4 plus 5 or 1 plus 0. Like if you want to take any of these numbers. Of course, if you're taking these numbers, then they're like too small. So like you can't actually use them. And similarly for 4 mod 8. So like, yeah, you should notice that 5 is not there on the board at all. Like any number 5 mod 8 is not on the board. So you can't get any number of this form. And also 0 mod 8, same argument. And then for 4 mod 8, you notice that 4 plus 0 is 4, which is, again 0 is not there on the board. And 1 plus 3, for that again 3 is not on the board. So yeah, this proves that these numbers can never be formed. And the second part of the proof is that the other numbers can be formed. So like you know that the numbers on the board are going to be this form, but now you can't, like if you have a 1 mod 8 number on the board, the next number cannot be 2 mod 8 because you have a 1, and the one after that, it can't also be 3 mod 8 because you have a 2. So it has to be 4 mod 8. And for 4 mod 8, again, you can use like a similar argument. So yeah, did everyone understand this? Did I go too fast?
No, it makes sense.
Okay,
Yeah, got
everyone.
it.
Yeah, it was
Yeah,
fine.
clear.
Also, since we have touched upon this, there is one thing I forgot to mention in the general tips and tricks. So this is like IOQM. No one is asking you to prove anything. So if you do some base cases and you conjecture something, and like that conjecture is just working for a significant amount of time, you might as well consider that the conjecture is actually true and just like finish the problem. It's a risk, but it's since if the conjecture like makes a lot of sense and it is working for the first few numbers, maybe you can just assume that it will just work overall. I mean, it is
Can you
not a very foolproof
elaborate more on that
strategy.
bashing technique?
Sorry.
Can you elaborate more on that bashing technique?
Can you elaborate
Like
more on
what is
what?
in general is what bashing is? Like I am not aware of it.
Oh, what bashing is?
Yeah.
Bashing is basically like case bash. Or in if you're talking about the geometry bash, then like we'll come to that when we start geometry.
Elaborate on the case bash.
A case bash is basically like, for example, you have like assume you don't know the stars and bars method, and you are asked the question, you want to distribute like three distinct coins between three children, and it's not given that you have to like consider each child gets one coin. So like nothing is given except for this. So you have possible arrangements like assume first, second, and third child. So yeah, the first child could get 0, and the second child could get 0, and the third child could get all three of them. This is one case. Then the second case is the first child gets 0, the second gets 1, and the third gets 2. Then another case, like I'm just eliminating these. So like 0, 0, 3 is a one case, 0, 1, 2 is another case, 0, 2, 1 is another case, and 0, 3, 0 is another case. And then you do a similar thing for the first child getting one coin. So like 1, 0, 2, 1, 1, 1, 1, 2, 0. So yeah, you get these 10 cases. And then again, for each case, you need to consider like, in this case, there's only one possibility. So like you get 1 plus, then in this case, there are, for the coins to variance, there are two possibilities, like, sorry, three possibilities. Like this guy could get any one of the three coins. So like that's again a +3. Similarly for this, and for this, it's again +1. This is again +3. Then this case would be +6 because any child can get any coin. So yeah, this is +6. Uh, so yeah, like these are basically very similar to these cases. So you can just assume them to be the same. And yeah, this gives you the final answer. But like this is a very slow method and it's like quite inefficient. So if you can reduce the problem more to something nicer, then it's like better. Yeah. Did you
Okay,
understand what case batch?
okay, got it.
Can I ask a question about case bash?
Yeah, sure.
So suppose I'm case bashing a stars and bars question. So how do I decide if this is like terrible in terms of time consumption?
Case batch is usually always terrible in terms of time consumption, but like if you have like a small number, like let's say up to like 6 or 7 even maybe, then it's usually like bashable. But if you have something large like 20, then like definitely not bashable. Like maybe a good rule of thumb is like think if it's one digit, then you can case bash. If it's not, then like preferably don't case bash.
All right, thanks.
So people are asking more examples of invariants. We'll not take them right now. Tomorrow you have an entire class on invariants, so you can just attend that.
Yeah. I think is that all for comp?
Yes, I think so. We can move on to Geo.
Geo, the most annoying part of IOQM.
Yeah, so IOQM Geo is almost entirely always computational. You don't need like what you, I mean, what the elegance or things you do in normal Geo, like inversion, projective, and stuff. You don't really require that in IOQM. You just need to memorize all the computational theorems that you know. Like you have Stewart's theorem, Pythagoras, Ptolemy's theorem, then the in-center, center configuration, K, lengths, and stuff. All the trig formulae like sine, cos. Uh, yeah, so Ptolemy in-center, center configuration, the trig formulae, sine rule, cosine rule, etc., etc. Uh, the expansion of sine of a plus b, tan of a plus b, and stuff like that. Power of point is very essential because um, power of point is it is a recurring thing in IOQM Geo. After this, okay, you need to be good at like basic angle chasing. Like you need to spot similar triangles for ratio chasing and stuff. Then sometimes you can try to coordinate bash, like just set up some coordinate system and do it very quickly. Okay, now these are some cheat tricks. Like if the construction is feasible, like for almost entirely always the triangle is given as a complete information in IOQM. Like in some ways you should be able to construct the figure. So if the lengths are small or you can dilate them to some point, you can try actually constructing and measuring the thing. That is not very bad as it looks like. I have done that once last year, so I mean, it is not as hard as it looks like. So if you are like in the dying minutes and you can't think of anything, just try constructing very quickly and measuring what is it. So technically, you will get some error, but since you know that the answer has to be integer, you can try to approximate up to that error. It's a very good chance that you will get it correct. Another cheat sheet is that you can, if nothing more explicit is given about a triangle or the quadrilateral, you can assume that it is an equilateral triangle or it's an isosceles triangle, right angle triangle, according to what is suitable in the problem. Or just assume that the quadrilateral is parallelogram or it's a rectangle and just compute the whatever is supposed to be computed in terms of this. Again, for this, you need to just remember this is a cheat thing, so you need to just verify that all the conditions are actually satisfied. You just can't assume that a quadrilateral it's a rectangle when it is just given that it's a kite or something.
Also, do not bring a protractor to IOQM. I think it's illegal.
Yeah. Bringing IOQM protractor is illegal. That is true. Oh wait, no. IOQM is it illegal or
I'm
allowed? I
pretty
don't
sure
know.
it should. Like they wanted to avoid these kind of cheat tricks, right?
Yeah, it's not
Makes
allowed.
sense. Yeah, makes sense. I think
Yeah,
ruler compass is allowed, right?
we
Pretty
A
sure.
even
ruler
got
compass is allowed, yeah,
multiple.
and that's
Yeah.
basically enough to construct everything.
Huh.
Yeah. Also, like there are some tricks for like remembering formulas. So first of all, for Stewart's theorem, I think you guys might have heard of uh the famous a man and his dad put a bomb in the sink. So yeah, that's a helpful mnemonic to remember the Stewart's theorem. So it's basically simplifies to this. And the triangle is like this. Oh, this is M, this is B, this is C, this is N, and this like whole thing is A, and this is B. So yeah, you can like remember Stewart's theorem like this.
You should also tell the mnemonic.
Yeah, it's like so that's for Stewart's. Then for Pythagoras, you need to remember some triplets because like if it comes on a problem, like the lengths are 30, 40, and 50, like you can just instantly say that this triangle has a right angle, and that makes stuff extremely easy to calculate. So remember the important triplets 3, 4, 5, and multiples of these obviously. So yeah, there's this, then 5, 12, 13, 8, 15, 17. And like the general form of Pythagoras is, I think it's like 2mn m squared minus n squared and m squared plus n squared. This is the general form. So like if you get numbers of these form, you can assume that there's a right angle. And a triplet which like is very important and very weird is this one. So yeah, you should like remember this kind of stuff.
That's a 20.
Yeah, that's 20. Yeah, it looks more like 20 now. Okay, yeah. In center Ptolemy theorem, like I'll just go over these theorems briefly. So basically, if you're given a cyclic quadrilateral A, B, C, D, and it has like diagonals. So then AB times CD plus BC times AD is equal to AC times BD. This is Ptolemy's theorem. And the in-center excenter configuration is also very useful. It's like if you have a triangle ABC and the in-center is given and the A excenter is given. So you basically have this property that if you draw the circumcircle of ABC and you draw this line. So first of all, the important things are it will intersect this point, like assume it intersects the circumcircle at M. So then M will be the arc midpoint of BC. And another important thing is MB is equal to MC, which is equal to MI, which is also equal to ME. So like BICEA is a cyclic quadrilateral with center M. So yeah, this is a very important thing. And like also you have angles equal and stuff. So yeah, that's in center center lemma. Then sine rule and cosine rule is like
Menelaus and Siva.
Menelaus and Siva. I mean, sure, but like they don't really come that often. I mean, I have not seen a question myself.
Oh.
This is the sine rule and the cos rule. I keep forgetting, but it's probably like
Also, like there are some formulas for area, exactly. Like
this is
the
the cos
area
rule.
formulas in terms of R and sine stuff and
Yeah, we'll get to those. Power of point. Yeah, power of point. I hope you guys know. There was a class on this. You can watch that if you want more information. But yeah, if you're given a point P and like this kind of thing, a line passing through P, any random line, P could also be inside the circle. So you have PB times PA is a constant value, and this value is equal to uh, PO squared minus R squared. This is power of a point. Then angle chasing, I mean, you guys know what angle chasing is. For chord bash, uh, you basically take the points in the problem to be coordinates, but like this is going to be very, very messy. And like really, do not try this in Algebra. It's like horrible. Yeah, and the area formula.
Oh yes, area formula is like there are like this 8 9 formulas of area you should just like remember. So one is like ABC by 4R. Then you have S into R, SA into S minus A into RA. Then you have the
We'll
Heron's
just.
formula. Yeah,
Should I just write the notations first?
yeah, sure.
What's RA? Or okay, you're telling.
Yeah, ABC are the side lengths.
X will be side.
A is like they used to denote BC, and so on. R is equal to circumradius. R is equal to n radius, like the small r. S is semi-perimeter, or then delta is area, and RA is equal to the x radius uh, with respect to A. So like in this case it would be like the circle would be something like this probably. The x circle, AX circle. So yeah, this would be the AX radius. Like this would be RA. But yeah, I don't know. Yeah.
Yeah, so then you have the Heron's formula S into S minus A into S minus B into S minus C. Under root, of course. Yeah. Then under root of RRA RBRC. And obviously of the standard one, height into base by 2, BH by 2, that is like just assumed. And if you're doing trig, it is half BC sin A. And yeah, half BC sin A and 2R square sin A sin B sin C.
Uh,
Yeah, so I think we can do a problem now.
There was one more, like it was A square sine B sine C by 2 sine A.
Can you repeat that?
A square sin b sin c by 2 sin a.
Yes, that makes sense.
Yes, it does. Yeah, so
Okay.
yeah, these are like all important. I mean, they're not like that hard to remember. They're basically symmetric. And of course, if it holds for A, then it also holds for B and C. So yeah.
Okay, since we're like running out of time, we will do one problem for geometry. We had actually planned 2 or 3 problems, but we'll do one problem, and if time permits at the end, we will do another one.
Actually, are you guys fine if this class gets like a half-hour extension? Because like,
No issue.
Okay, sure. Then we
Yeah,
can
fine.
do
Yeah, it's
problems.
fine.
Yeah.
okay.
I mean, I have one question. I mean, like, I'm confused whether should I use the book Challenges and Fill of Pre-College Mathematics or Euclidean Geometry and Mathematical Olympiads for the IOQM geometry?
Yeah, challenge and thrill is extremely outdated. Do not use it for Olympiads
Yeah,
at all.
CTPCM is, I don't know, no one uses that.
It's like 1990s stuff. Boomer books.
But like,
Uh,
I don't think you will require the entirety of EGMO for the IOQM. I think only first 4 chapters are should be enough.
Not even that. I think like the first chapter should be like enough. It's
Where is
even
Rigbash in EGMO? Rigbash is like 4 or something, no?
nah. You don't trick.
Right, I think.
Okay.
Yeah, they just like the first 4 chapters. I think you can like go through them. Don't even like attempt all of them because like they have pretty hard problems as well.
Yeah, yeah. You should attempt it if you're like preparing for INMO and stuff, but for IOQM, basically just going through it should be enough.
For IOQM, you can like just go through whatever you have told. That like basically should be enough, I think, and like
Yeah.
practice problems obviously.
Okay, so should we do problems right now or should we do them at the end?
In now or later.
Okay, let's do one problem right now and maybe we can do all the other problem later.
Yeah.
So, okay, so what we have right now is, okay, I forgot what we had. Okay, so we have a circle. Okay, this is supposed to be 90. We have its in circle. We have a tangent to the in circle. Tangent. So now you are given the information. Okay, this is 90, like 30, 40. So obviously this will be 50 and stuff. XY is equal to 48. Wait, what was supposed to be computed? You have to compute Tx into Ty. Right now, it's fine if you don't do all the computations. If you just get the idea how to compute, you can just say it out.
Can we draw it C-centric instead of like B-centric?
Sorry?
Can we draw it C-centric instead of B-centric?
Yeah, yeah. Look, IOQM, you can rename it however you want. No one cares.
No, like we can draw it that way because like XY should be then parallel, right, to AB. XY
It's it's
only.
it's not parallel. It's not parallel. It's like a random tangent.
Oh, it's a random tangent, my bad.
Yeah.
With 40 is
Wait, do
XT.
we have to
You are
find
just
the
given
XT
this
here?
length. Yeah, you have to find this.
Okay.
Right.
Oh, okay. I should have mentioned this
We can
earlier.
know R
Sorry.
by, like, we can know easily know R first.
Yeah. So you obviously know circumradius. Circumradius is 25. You also know end radius.
Yeah.
End radius is s minus b. So what is s here?
In radius, you can get by like
60.
Delta by S is better, I think.
60.
yeah, exactly. Delta by
For,
S is like
okay, for
much
right
better.
angle.
10.
Okay, I just said for right angle triangles, like in and x are like really trivial. So if you have s for right angle triangles, then in radius is just s minus b, where b is 90. RB will be s, and I think rest of them
10.
swap or something. I don't remember exactly. I think this is s minus c. I don't remember this exactly. This let just confirm. They either swap or they remain the same. I don't remember. but these two are like very good.
Wait, what is T point? Is it given? Or like it's random tangent?
T is a random point such that the tangent at T on in circle intersects circumcircle on x and y, and it is given xy equal to 48. So R will be something. Okay, I will not write them right now because like we will not do computations right now. Or should we? I don't know. Otherwise, should we do the computation?
Computation I think
Yes.
is like 2.
R
X
is
thing. Yeah, R is 10. Okay. What's next?
probably IT would be nice to write, like probably something like IX and IY.
We need to compute IY, like kind of.
Can't we compute power of T in with respect to like
Yeah, like we have R, but we don't have OT. OT lies on AC, but we can't. We don't know the distance.
How much is XY?
48.
Yeah, also for everyone asking, yes, I will like take photos of like screenshots of everything we have written down and we'll share it as a PDF on OMC. No need to worry about. And also there's a recording if you want to
Yeah, it
watch.
will be uploaded tonight, latest by tomorrow.
Okay, so like I guess we can compute IY. First, we know that the perpendicular from I to AB will be some, like, we know it's R, and we also know that. Can you draw the point, please? Let let it be like something, anything.
Oh yeah, yeah. We'll call it X. Oh no, wait, that's already used. Z.
Yeah, so we know BZ because it's S minus something something, and then we know by Pythagoras we know IB, and by similarity then we can know BY as well. So we can calculate IY
Wait, how will you get by?
by similarity. Like
Oh,
we know the radius, X radius, we know the in radius, we know one line, so we know the other line as well.
come on. Similarity between which
Oh,
triangles?
sorry, my bad.
Yeah,
I thought
T.
Y is the X radius. My bad.
No, no.
X.
Yeah, so what he said, like constructing perpendicular. So like, yeah, one more cool thing about right angle triangles is that you draw this, uh, the perpendiculars from I to the like the feet of like not the feet, but like the base, the non-hypotenuse sides. Yeah. So it forms a square. Like if you call this point P, so like I Z B P is a square, like always.
Not exactly a solution, just maybe in one direction. But like maybe we can kind of put xt as x and ty as another variable. Then we can just try to work out x in some way or the other. That will then we would have to forget about the fact that we have a.
Sure. I think we should like go ahead with the solution. Arnav.
Okay, sure. Yeah. So, okay, I will, what is, I'll just draw a simplified figure. So, let O be the circumcenter. This is I, this is T, this is line X, Y. We'll draw perpendicular from this to here as well. Okay, it's not perpendicular, but like, just assume it is perpendicular for now. Okay, so since you know that tx into ty is equal to basically to square minus r square. So if you calculate to, you are done. So now what you can do is, in this figure,
R square minus TO square.
acha, okay, tx into ty is negative. So okay, let's take the mod of this. Sure. So now the thing is ki, okay, I forgot to mention this earlier. OI square is equal to r square minus 2rr. You should memorize this.
Yes.
So you can calculate OI. So basically you have this figure. It's a trapezoid.
What's RR?
The capital R is circumradius, small r is in radius.
Oh, it's product, sorry.
Yeah, so you have O, you have I, you have T, and you have some random point M. So you know OI, you know IT is circumradius. Also, since XY ka length is known, you can calculate OM, right? So like just drop a perpendicular here, do some computations. Using this, you can calculate OT, and then you're done, because like just do OT square minus R square, come out, and you will get that is just power of T with respect to the circle.
N is like the intersection of XY with AC.
No, M is the midpoint of chord XY. So perpendicular from O to XY.
Wait, can't we just like translate IO by like OM and like make a like right triangle?
Translate.
IO by
I,
like length OM.
so it will be somewhere here,
Like OM, O should match with M and I stays the same.
like this.
Yeah.
Okay, sure. I mean, there are a lot of solutions to this. What I did was like I dropped this here. So this is a rectangle. You know this whole length. So you know this length. So you know this length. Apply Pythagoras, can compute this and like calculate the diagonal. Is that okay?
Yes.
Yeah, and this is why IOQM is like quite annoying because you need to like usually do 2, 3 constructs and apply like a lot of formulas and stuff. And it's like hard to see usually.
Yeah, and like it's also calculations. So if you mess up any one of those, you are cooked.
Okay.
Was it like
This,
a 3 or 5 marker?
this was not
2.
an IOQM, but like probably no, not 2. It's not that easy. I think like a 3 marker.
Okay, we can now do number theory, I think.
Yes.
Okay, for number theory, what we have is, again, you need to know, okay, let's start with this thing. You need to know Fermat's little theorem, Wilson's theorem, Euler's theorem. These are the standard ones that you need to know. They won't ask you anything directly, but you will find that easy by eliminating cases, doing computations and stuff. Yeah, Fermat's little theorem, Wilson's theorem, and Euler's theorem. You need to know quadratic residues of some basic things. So quadratic residues with respect to 2 is like basically 0 and 1. I mean, obviously. Yeah, quadratic residues with respect to 2 is basically 0 and 1. 3 is again 0 and 1. 4, 0, 1. Yeah, 4 is also 0 and 1. 7 is what, 0, 1, 4, I think.
5 is
0, 1,
0.
2, 4. Yeah, 7 is 0, 1, 2, 4. 5 is 0, 1, 4, yes. 8 is 0, 1, and 4. Okay, so a good thing to note is that all the odd numbers are congruent to 1 mod 8 ka square. 9 is then, oh, he wrote 9, that's good. Okay, 10 we don't really need, no? Okay, sure. Likh lo.
10 is like just last digit question kind of.
Yeah.
Can you just brief me about what are quadratic residues?
Yeah, so these are the modulos that any square can leave when divided by the specific number. So if you take any square number and divide it by 9, the remainder you get, it will always be 1 of 0, 1, 4, or 7.
Do we need to
Okay,
memorize
got it.
this?
You can derive it on the spot as well, but like, I mean, if you just read this for like 1 or 2 times, you will just memorize it anyway. You don't have to memorize it actually.
All right, cool.
Okay, Kushagra has raised hand. Oh, he lowered.
No, by mistake.
Yeah,
Okay,
also
sure.
important stuff about this is like, for example, now mod 10 quadratic residues. For example, if you're doing a calculation and you get something like you get 31 squared is equal to 971 while accidentally. So like to recheck these calculations, the quadratic residues are helpful. Like you see that 9 plus like, this is basically 8 mod 9. So like you know that you have made a mistake in the calculation. So like yeah, it's also an efficient tool for checking calculations.
Yes, so we have this. Uh, Another thing is, wait, what was that? Okay, Sophie Germain. Sophie Germain is like extremely useful in IOQM. We will do a problem based on this also. So Sophie Germain identity, Atharva will write, I think, a to the 4 plus 4b to the 4 is yeah, a square plus 2b square plus 2ab. Yeah. So this pops more often than you think. So you will find it very useful. We will also do a problem in like 2 minutes. Another thing is, yeah, multiplicative inverses. I mean, these just, it's good to know them for some prime modulos, but like, I don't think it's used that much in IOQM. I'm not really sure, but you might also know it for, like, you just know it. Okay, yeah, I think we can do a problem, or is there anything to add?
Yeah, okay. So yeah, here's the problem. It's an IOQM PYQ. I think last year it was problem 28. You are given
Find the largest integer less than 30 such that n to the 8. Yeah, I'll write the expression.
uh,
Is not divisible by square of any prime. Yeah.
Can't we just factorize it unless I'm
I
hallucinating?
mean, do we try to factorize it?
Yeah,
yeah.
obviously.
Yeah, obviously.
So yeah, how does the factorization go? Can anyone just say it?
n power 4 plus 4 times n power 4 minus 1.
Yeah, and keep going.
Okay, you can probably factorize this a bit more.
Yeah,
Why, Sophie? N power 4 plus 4 gives like
Yeah,
n square minus 2 plus minus 2 and plus 2 1 plus 2 and plus 3. Yeah.
so like
n
half
square n
n
power 2
minus
minus
1
1.
times n plus 1 times n
Yeah.
square plus 1 times n square plus 1 times n square n minus 1 square plus 1.
yeah.
Yeah.
So this is the expansion. Okay.
And now GCD stuff, I guess, like some of them might be co-prime.
Yeah, exactly. So yeah, does anyone want to like do the case batch complete? Like
Is it like we look at 2?
yeah. So first you look at 2. So what you get is that assume n is odd. then n squared plus 1, n minus 1, and n plus 1 are all even. So this whole thing will divide, um, like will be a multiple of 8. So like after you divide by 2, the whole thing will be a multiple of 4. So you get that n has to be even. Okay.
Then probably look at 3.
What does it give you? Because like if n is 0, then this would be like 1, this would be 2, this would be 1.
All right, yeah, it'll become like this. My bad.
I mean, like basically getting 3. I mean, you should try 3 in contest, obviously, but like 3 doesn't work in this case. You should try like mod of all 1 to 10 probably. Like it's quite helpful. Okay, so what do you do after 3? Oh, guys, speak up. Like it's like just case bash. I mean, you can just like tell me what primes to use.
Mod 6 should be nice, right?
Mod 6.
Mod,
6 is not a prime though. Like you
yeah,
want it to not be divisible by prime. So like
I mean, can, okay,
I mean point is if it's divisible by 6, then it's divisible by 2 and 3. And we have already covered those cases. So
It's like 5 numbers, so mod 5.
yeah, sure. So you go mod 5. So like what do you get?
If it's 0, it's like, okay, sure, but x0 mod 5. 1, I think n squared plus 2n plus 2 and n minus 1 is divisible.
Yes.
For minus 1, I think n squared minus 2n plus 2 and n plus 1 is divisible.
Yeah.
Then for 2, probably n squared plus 1 and one more. N squared
Yeah.
plus 2n plus 2.
Sorry, for 2.
For 2, it's like n squared plus 1 and n squared plus 2n plus 2, I think. Wait.
Like we
Yeah,
can't,
that
we
makes
don't
sense. Yeah.
want to consider like n and p minus n, like they are just the same in.
Yeah, and then n squared minus 2n plus 2 and n squared plus 1 for minus 2.
Yeah.
So
So you
like
get n is even and you get n is 0. And now you have reduced it to 3
n
cases.
is
Like
a multiple of 5, I think.
yeah, n is a multiple of 5 and n is
10.
even. So like you
And
basically reduce it to
just a thing to note is that you could have used Fermat's last theorem here, Fermat's little theorem here, my bad.
All
Like
right,
in
yeah,
the
n to the 4 minus
above
1.
expression, you have n to the 4 plus 1, n to the 4 minus 1. So if n is not divisible by 5, n to the 4 is equal to 1 mod 5. So both of those brackets are divisible by 5. The whole thing is judged by 25.
yeah.
Yes.
So
Okay.
you get 5 divides n, and now just check for 25 and 20, and you will be like done.
Yeah, like you substitute you take 10 and 20 and like you get that 20 actually does. Like, I'll just do it quickly. Um 3 into 7, this would be 19, this would be 401. This is like 362 and this is 442. So and you just like factorize this quickly and you get that this actually works out.
Yeah, okay.
Yeah, you could rewrite n square minus 2n plus 2 as in a better form. Yeah. Okay. So yeah, this was a 5 marker like last year. So yeah, this like these theorems are very helpful. So yeah, I'll just go over these for people who don't know. Fermat's little theorem is basically a to the p minus 1 is congruent to 1 mod p such that p does not divide a. Everyone is comfortable with the notation, right?
Yes.
Okay. And p is prime. This is extremely helpful. Then Wilson's theorem is like again, P is prime. So yeah, P minus 1 factorial is congruent to minus 1 mod P. This is also very helpful because like factorial problems do come in IOQM. Euler's theorem, it's basically like, I think a to the 5 is congruent to 1 mod n. Oh, hang on, wait.
If he is co-prime to n, I think.
Yeah, A has to be coprime. Yeah, exactly. For those of you who don't know what phi function is, basically, if n can be written in the form as p1 to the alpha 1, p2 to the alpha 2, this is a prime factorization. This is the phi of n is equal to p1 minus 1 by p1 times p2 minus 1 by p2 times and so on times pn minus 1 by pn times n. Oh, wait, this is like that. Yeah. Yeah, so this is phi of n. And also phi of n is defined as number of naturals less than n such that GCD of a comma n, like whatever the number is equal to 1. Like the number of naturals less than n such that they're co-primed. So yeah, this is the phi function. Yeah, that's it. Yeah.
Yeah, I
Uh,
think is that it for the class or is there anything left?
I think this is all we wanted to cover, right? Are there any more problems?
Uh, I don't think so. I think we covered all of them.
Okay.
Oh wait,
Do
that
you,
yeah.
somebody asked something in the chat, something about fireflies last year.
I guess Legendre is also useful.
Yeah, that is also quite important.
Okay, to yes.
Legendre is basically like the largest power of p dividing n factorial. So like let me just
Also GIF stuff, I guess.
this stuff. I mean, like what exactly in just stuff? Like basically, GIF is the greatest integer function, which is like, it's pretty self-explanatory. So yeah, it's a formula for the largest power of a prime dividing n, which is basically floor of n by p plus floor of n by p square plus and so on. Like eventually this becomes zero, obviously. So yeah, for example, if you want to calculate like the largest power of 2 dividing 10 factorial, or like 10 is small, you can do this manually, but like for example, let's say 50. So you get that this would be 50 by 2 plus 50 by 4 plus 50 by 8 plus 50 by 16 plus 50 by 32. And like the next power is going to be 64, which is greater than 50. So you can just stop at this point. So this would be like 25 plus 12 plus 6 plus 3 plus 1, which you add and you should get 47, I think.
I think in the formula for phi of n, there's supposed to be the exponents plus 1 the numerator.
+1. Hang on, what?
Oh, right, the n is there.
No, it's yeah. Oh, is there like I think we're done with the class now.
Yeah, I think that's it.
Oh
Anyone
yeah,
have any questions?
I think somebody was asking this IOQM last year's IOQM problem. Oh, I'll just share it so that you guys can try.
Yeah.
Also, if anyone has any like doubts in general about IOQM, you can ask.
Yeah, like any questions you want to ask, strategies, stuff.
Guys, can you like you said about attempting IOQM marks, right? So where can you get a lot of marks? Like just do we
Uh,
So
see or something?
MOMC, you can get a lot of marks. You can.
Okay.
So do you have the website or something?
yeah, the website is agamji.com. It has like I think 10 marks around or maybe more.
Yeah, I mean, there are like a lot of marks from previous years also. You can try that. They're like very good marks. It has a lot of
Just
marks.
remember that these mocks are going to be like slightly harder than IOQM, so like don't feel demotivated if you get low scores. Like even if you get like let's say like 10 or 15, it's still like a pretty good score in those mocks.
Wait, what? A 10 or a 15?
Yeah, it's like a good score
Okay.
because like IOQM like in IOQM 2024, like people who got 10 in Agamjeet mocks got like 40 in the actual IOQM.
Yeah, and also OMC will be having one mock probably next to next weekend. We will soon confirm the details on the announcements. Also, if you want, we can share. I think we can share last year's mock as well, right? Or can we?
Yeah, we can share last year's mock.
Yeah. So just do a lot of mocks. It will help you a lot for IOQM. All the best for IOQM, I think.
I
Agamjeet.
have a doubt. Like I started my IOQM prep very late. Till now I'm only able to complete like my number theory portion, and I have my examinations right now. So my 10 days will be wasted in it as well. So I have geometry left and combinatorics is done. So for geometry, like what should I more focus? Basic theorems and more practice problem.
Oh yeah, the theorems that we have said, I mean, it should not like take more than a day to like learn all of them. Like whatever we shared in this class, and yeah, just try a lot of problems.
Yeah, I think at this point, I mean, I'm not forcing you to do it. You can try considering it. This was my strategy last year. Like I used to find IOQM Geo very tough, so I used to like skip it on the first attempt. So if you're not confident enough of doing Geo right now, you can try considering it. Okay, just like you said, you're done with NT, so try NT, try Combi, because Combi doesn't require any theory. So you could try NT, try Combi, try Algebra, and whatever you can. But and maybe after a point, you can try attempting the Geo. I mean, you will just work it out in the mocks. Just develop your own experience. It will be fine.
So, like the theorems of Keva and Menelaus you didn't mention. I mean, do I need to do them as well?
It will be good to know. They are not really very common in IOQM, but if you know them, it will be good.
So these theorem plus some basic properties will be good, right? Some basic properties of cyclic and all, like.
Yes, exactly.
I
Thank
feel
you.
like we can just make a small list of what you will need and we'll share.
Huh.
Yeah. Anything else?
For problems, are like AMC and AIME problems good?
Yeah, sure. They're good for practice. Or the first few problems of AAMC, I think like the 1 to 10, I think they're like too easy for again, but like the others should be fine. Also, I think like 20 plus problems are like hard, but like yeah, you can practice them.
All right, thanks.
Okay, I think that's it. I'll
Yeah.
stop the recording. We'll be there for like 2 more minutes, 2, 3 more minutes if anyone wants to ask anything.